Hey everybody, this is David Mars with Mars HVAC Services and Mars HVAC Air Design School. And today I'm working on a block load. I actually have it up on a different screen right now. I like to work with two different screens. That way I got it up on one and then I can do the work on the other, but unfortunately I'm not going to be able to show the other screen. I'm just going to show RightSoft for now and go through a process. So this block load, all I'm going to do is just the perimeter outside the house. I worked with many companies out there, and a lot of people kind of get this kind of mixed up with room by room loads. And when you do a heat load calculation, room by room means you go room by room, you draw each room, you put in your internal loads for the room, and then you put in your windows for that specific room, and then it breaks it down on a room by room basis. And you can also provide reports based upon the whole house then as well. It takes much more time, where a block load is actually something that doesn't take very long whatsoever. If you have things such as CoolCalc or RightJ Mobile, you can actually get it done in probably about 10 minutes for an entire house. It goes by very, very quickly at that point in time. But today we're going to do a block load. I'm doing it from information that was provided to me, and then we're going to go ahead and finish it up. So first thing I'm going to do is let's go to our project area, and I already have it set up for the weather location. We're going to choose Ocala, Florida for this one. I'm going to put my name in there. I'm not going to change the orientation yet. I'm going to look that up later on and then change that orientation at that point in time. But first, we're going to go ahead and modify this. We have R5. We're going to stick with those. Now, these are all libraries that I've set up, and I've already pre-set up. I've learned that setting up a template and setting up libraries saves enormous amounts of time. If you're using RightSoft and you're not doing it already, then you're repeating steps over and over and over again that don't need to be repeated. The things that only need to be done once, and then you just go over and do a pull down menu, and then you got 8 to 10 actions that don't have to get repeated again. All right, this is going to be under attic, and now I'm going to do wall by wall since I'm doing just the perimeter of the house. All right, first one is going to be 16. And if you notice, I got my grid settings on 6-inch. I found that 6-inch is like the perfect kind of Goldilocks area to be at when designing. 3-inch is just a little bit too small. It creates issues when you try and do a duct layout. Makes it really, really difficult. Maybe if I adjusted the snap a little bit, but I just found overall I really like 6-inch. 6-inch grid, 6-inch snap. All right, 28. And then we're going to go down with 30. 22. 4. 8. Now for 12. And 14. And then we're going to go back up. It should be 56. We'll see how far off we are. 56, perfect. All right, so we have the house drawn now. Now let's go ahead and we're going to put in some windows and doors. All right, let's see. Actually, let's go ahead and draw the garage in there. All right, let's go ahead and change our duct things. Trunk and branch perimeter outlets. Let's go for radial center of room, close to unit. We don't know, so we're just going to change these to average for the ceiling. Now, for occupants, it's a 3-bedroom house, so it's going to go with 3 plus 1. And then we're going to put in, this one I believe had a standard size kitchen. So we're going to do 1200 BTUs for the kitchen, 900 BTUs for the living room, and 500 BTUs for the laundry room. So if we take the laundry room, living room, and add that up together, then we have 1400 plus the 12, we're at 2600 BTUs. Now you may say, where in the heck did you get that information from? Hit that dot, 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 boom. Right there. Or I could have done this. This was something that they added in after the fact, after I started adding everything up in my head. And so you could also do the block load and click on this one right here for choosing. Like I chose, what was it, 2600? That's super close to the 2400. It's under the 34. I think that'd be a little bit too high, but it's within reason. All right, so now I'm going to click OK. And I got it at 9 feet for my average ceiling height. I'm going to change it to house. If I could spell today. There we go. All right, so now I've already looked up what direction the front door is going to face. It's going to be west. So we're going to put north going that way. So south is there, east and west. We're going to have a door here. And I'm just going to copy that door and put it right there. All right, now on here, I'm going to put it, the front door faces west. And now let's draw some windows. We're going to have a 4x6 window here. And then a 6x6 window. A 1x4 window. Actually, let's go for a 4x1. That's typical. It's most likely a bathroom or something right along in there. Now, granted, I don't know the rooms that are in here. I was just given basic information. I was told how many bedrooms are in it. Showing where the windows and the window sizes are located at. All right, and then we got some sliders to throw in. So we got a 12-foot slider. And then we got an 8-foot slider. All right. And that is that house. This is ready to be saved. And then the report sent to the contractor on this one. Because all I needed to do on this one right here was just figure out what the heat load was on it. But let's go ahead and look at this. We'll look at it right here. Now, here's one area that I like to show people. So we're at 1736 square feet, 40,125 BTUs. Now, this right here says required total capacity at 0.7 SHR is 4.4 tons, which means that with the sensible heat ratio, that at 0.7, which that is the difference between the sensible and the latent. People need to understand that. That's the difference between your sensible and your latent. 70% is your sensible, 30% is your latent of your total capacity. That is what your SHR means on this instance. So if you were to put that on that, it comes out to where you need a 4.4 ton if you're sizing by your sensible. If you're not sizing by your sensible, running at a 0.7, so say your area you need to size per sensible, then you need to go over and find out what your running SHR for that unit is. Which I don't recommend doing that. I would recommend doing a manual S. Manual S is far more accurate as being able to depict what the true unit size that's going to be needed for this, because you're matching the unit with the heat load of the house. And you're taking in a lot more variables. You're taking in a lot more different temperature sets and settings and stuff like that. But in this instance, some areas do things their own method in their own way, despite what recommendation is. So if you were sizing per sensible, and then you looked up and your sensible was at 0.7 for your sensible heat ratio, then you would need a 5-ton unit for this house to be able to make it size correctly. But you would also have to look up your SHR for the equipment that you're going to use, and sometimes the equipment might be at a 0.76 or 0.72 or 0.74. That's going to change this number right here. So the more that number 0.70 goes to a 0.80 or a 0.75, it's going to bring that 0.44 down to a 0.42, 0.41, or a 4.1, 4.2. It's going to lower that then. But this is not a depiction saying that that's the size that this unit needs to be. I'm hearing that a lot lately, and that is completely 100% inaccurate. If you want to size this house correctly, you need to perform a manual S. That is, according to ACA, according to industry standard, the correct method of doing this is we've performed a manual J, do a manual S based upon equipment that we think we want to put into the home, and see if the equipment is within 15% over the heat load of the house. If it is not, then it is not according to code. Now with this though, like I said, some areas have different codes that are into effect, and you might need to use the other way with sensible heat ratio, but I don't recommend it. But it's definitely not an area that tells you the tonnage of the unit. That is 100% not a true area that effectively tells you the tonnage that you need for this house. Just by looking at this, in my experience, most likely a 3.5 ton. Not 100% on a 3.5 ton though. Some of the 3.5 ton units out there, I mean, I've seen, sounds crazy, but I've seen really high efficiency 3-ton units that are only pushing out 39.5. So, I mean, if you're looking at your total amount, you're not going to meet your total amount then at 39.5. At that point, you might have to jump to the 4. So you always got to look at the unit you're doing and what the unit is capable of. And if you live in an area that has latent, I would always 100% make sure your latent is always taken care of for latent and moisture removal inside the home. If you don't do that, you're going to be in deep, deep doo-doo. That's a major, major area. All right, y'all. So that concludes this video of going over this house. I hope I gave you guys some really good tips on that. And I look forward to sharing some more videos with y'all. Y'all have a great day.